this is the type of problem where we calculate the electric field based on the size of the source charge and how far we are away from it. Source charge means we know how big the charge is that is causing the field in the first place. And so in this case, we know, they don't say the word source charge, they just say point charge. And then they tell us a location, how far we are. So let's draw a picture. We have, I'm going to call this point charge big Q, like to imply like it's the big one, okay? And it's positive 7.2 times 10 to the negative 6. And then the location we're solving for is east of that. So we're over here at this location, 1.6 meters. Here to here. Okay, so then when you write that out, well, we kind of already did, but let's just write this, R equals, although some of the equations on your sheet are going to switch to D later on, we're still sticking with R for this equation. So we're using a new equation now. It looks really similar to Coulomb's law, but this time for an electric field, we're going to use E equals big K, oops, sorry, times big Q over R squared. So you'll see that on your formula sheet. And so when we plug in here, we've got our K value, and then Q we wrote down. Okay, and the difference here is that we're not including how big the test charge is or any charge that would come into this field, because we're just calculating how big the field is that is caused by this big point charge. Okay, so then when you do the math here, you can do it all at once. If I was going to do the numerator alone, I could do that, so maybe I will. Like, I would get on top, I have one of these cancels one of those, and then don't forget to square the denominator, so I'd have 2.56 meters squared here. Those cancel. So then I again get my units that I want. But let's finish the math. Okay, so then I get a really big field strength here when I'm this close. And I'm going to keep, well, I really only can keep two sig figs, so then I would say 25,000 newtons per coulomb. Now that's the strength. And then if we were to stick with the book's definition of direction of an electric field, then I would define it based off of what a positive would be. So if I put a positive charge right here, which way would it want to go? Well, it would be repelled by my positive big Q, so the direction would be also east. So that's what the direction I would put here, since it told me east. Now you could write to the right, but since they told me east in the original problem, I would also tend to write east. Okay?